My name is Mete Atamel. I'm a developer advocate at Google based in London. Hopefully you are doing well wherever you are. We've been on lockdown since pretty much Christmas, but I think we're getting closer and closer to the end, hopefully in the next couple of months. Today I want to talk to you about choreography and orchestration in serverless microservices. The way I want this presentation to go is that first I want to explain these notions of choreography and orchestration, what they mean, what are their pros and cons. Then I want to look at the landscape in this area and look at some of the tools that help with choreography, that help with orchestration. Then I will switch to orchestration and look at a specific tool from Google called Google Cloud Workflows to see what kind of things Workflows provides for orchestration. Because I feel like event-driven systems choreography is well understood. They've been around for a while, but orchestration is relatively new. So I just want to deep dive into that a little bit. And then if we have time, and this is a big if, I want to talk about an app that we rewrote. It was an event-driven app. We rewrote using orchestration and some of the things that we learned from that app. But if you don't have time, I will share the links of that app and also a blog post that explaining what we did there so you can read more about it. And also the presentation is already on speaker deck, so if you want to get the presentation afterwards, feel free to get it. All right, so let's talk about choreography and orchestration, and let me do this through a scenario, an imaginary scenario. Let's say you have an e-commerce website, and in this e-commerce website you have a checkout process. In this checkout process, a user sends an order request. Then you want to authorize and charge the credit card of that user to make sure that they can pay for what they ordered. Then you probably want to prepare and ship the items for the user. And then you probably want to notify the user with email or something else to let the user know that their item shipped. Now, if you want to design such a checkout process, one way of doing this back in the day, what we used to do is we used to create a single monolithic application that did all this work basically, right? But nowadays we are doing things in microservices. We are doing things in separate small services that do one thing at a time. So you might, for example, if you're on Google Cloud, you might have a web app engine front end that receives the request. So that's the web front end. Then that will pass the call to a payment processor that might run on Cloud Run, which is Google's serverless container service that will authorize and charge the credit card. Then once that's done, that will make a call to a cloud function, which is a functions as a service platform of Google that will do all the work for preparing and shipping the item. And finally, maybe you call another notifier service, which is again a cloud run service to notify the user using something like SendGrid, right? So you broke down the monolith into small microservices, and now from each service you're calling the next service, right? So this is one way of solving the problem. Your services calling each other directly. But when we look at this model, there's pros and cons. The pros is that this is better than having a single monolith for a number of reasons. You can have services scaled independently. These services, they do small things, so you can reason about each service independently. So it has a lot of advantages compared to monolith. And also, this is easy to implement because each service just calls the next service, right? So all you need to worry about if you're a service is that, what is the next service that I need to call? Now, in terms of cons, you have too much coupling between all these services because front end needs to know about the payment processor needs to know about the next service, shipper, so on and so forth. So you have to somehow hard code that information or get the information kind of injected in runtime, something like that. But this is already too much coupling between services. And each service can be a single point of failure. So what if some service in the middle breaks? What do? The whole thing basically breaks. And then when things break, you need to decide what to do. You need to raise an error, or maybe you want to retry a couple of times before giving up, right? So you need to have this error and retry logic baked into services, and not just one service, but all of the services, right? So you're already having more logic in your services than you actually need. And for me, the most important part is that who actually ensures that the whole transaction is successful, right? If something fails, who retries things? And if something needs to be escalated, who keeps track of that? There's nothing like that in here. You have to build that in. Now, we can solve some of these problems if we switch from services calling themselves directly to what's called an event-driven system, also known as choreography. In this model, instead of services knowing about each other or calling each other directly, what you do is you use some kind of a messaging framework. So you have a message broker as the backbone, and each service basically receives the messages that they care about and emits the messages when they're done. So front end, when it receives the request, it will receive the request and it will create a message order received kind of message. This message will be put into the message broker. Then the payment processor is the one that cares about new orders. So it will pick this message, then it will process that message, and it will emit another message saying the payment is processed. So here's the shipping information, so on and so forth. But in this model, as you can see, the services, they don't know about each other. They don't care about each other. They just specify what messages they care about, and then they emit messages when they're done, right? Now, this is good, but imagine a more complex transaction, right? Because the transaction that I'm talking about, this is imagine a scenario. It's a simplified scenario, but imagine you have something like this where, you know, when you receive a request, you have to check an inventory. Then you have to see if you have stock or not. If you have stock, you do certain things. If you have no stock, then you do certain other things. So you have some kind of branching. And maybe if you're out of stock, you need to call a third-party API. And then at some point, you need to update your inventory again, then so on and so forth. So imagine doing this in an event-driven way. I mean, it is certainly possible, but it's getting quite complicated because you're going to be dealing with lots of different event types, lots of events flying around. And if something fails, like it's not so obvious like where things are failing. So when we look at the pros and cons of choreography, event-driven systems, obviously the pros are services are loosely coupled. They can be changed independently. They can be scaled independently. You don't have a single point of failure because if a service fails, the other services, they still respond to messages so that they don't necessarily need to fail. And events are very useful to extend your system because if you need to add a new service into your system, it's just adding the service and specifying what kind of messages it's interested in. So you don't need to change anything else. It becomes really easy to extend your system. Now, in terms of cons, as I already mentioned, difficult to monitor the whole system. Errors and retries or timeouts are still problematic. And you know, the business flow is not captured explicitly, right? Like, for example, when we look at here, the business logic, it's quite clear what should happen. But when you convert this into an event-driven system, you kind of lose that. You know, things may be happening this way, but there's no single place you can point and say, this is my business logic. And for me, the biggest problem is still there. You know, who ensures that the whole transaction is successful, right? You still need to do that somehow. Now, to solve these problems, we can go with this new approach called orchestration. And in orchestration, the idea is basically instead of services calling each other or instead of services emitting messages and receiving messages, why don't we have an external service, an orchestrator, that basically orchestrates these calls? So you receive a request, maybe you still have a front end, and the front end calls an orchestrator, which is an external service that calls the services in the order that they're supposed to be called. And the orchestrator can also make sure that each call is successful. The orchestrator can also make sure that each, if there's an error, there's a retry, things like that. So in this model, you're not sending messages, but you're actually making calls through the orchestrator and doing it in a central kind of place. So when you take this approach, the pros and cons, again, there's obviously pros and cons for this as well. The pros is that you have this centralization, and because of that, you can capture business flow centrally and source control that. And this has a lot of advantages that I'll talk about. Each step that the orchestrator makes, calls, can be monitored. And then if there's something wrong with the step, you can actually apply error and retry policies to make sure that you can basically be consistent about your steps. Usually in orchestrators, you are dealing with simple REST calls. So you don't have to deal with events, different types of events, and parsing those events. You're dealing with simple HTTP calls that the orchestrator makes, and this kind of simplifies things a little bit. And you still have services independent. So you're not centralizing at the expense of microservices. You have the microservices, they're still independent, but you have the benefits of someone central calling them. That's the good thing about orchestration. Now, in terms of cons, an orchestration service is something new that you need to worry about. Orchestration service can be a single point of failure, so you need to make sure that your orchestrator is actually resilient and redundant and things like that. And reliance on REST ultimately means that you're losing some of the flexibility of eventing. So you're tightly coupling your services a little bit because of reliance on REST. So it's not so easy to introduce your service anymore. You can just introduce and it just works. You have to introduce and make sure that the orchestrator also calls that service. So there's a little bit of more work involved there. So which one is better, choreography or orchestration? And the answer is it depends, right? The way I think about this is that in choreography, if you have services that are not really closely related, for example, you have a payment processor and you have a notifier. These two services, they don't really need to know about each other. They're not really related. For those use cases, you probably want choreography, right? Because they don't really need to talk to each other all the time. And in also cases where you have a notifier in a checkout process, but maybe you want to use the same notifier in some kind of other context, right? For those use cases where you can use the same service in different contexts, maybe choreography is better because you can plug in services in a much easier way. On the other hand, if you have a business logic and you can define the business logic in some kind of like a flow chart, then maybe at that point you should think about orchestration, because there's a lot of value in capturing the business logic and then having a central orchestrator kind of acting on that business logic. And also, if your services are closely related in some kind of a checkout process, for example, and you always kind of deploy them together and you always call them in a certain order, again, maybe that's a good candidate for orchestration. And also, if you just want to stay in simple HTTP calls without having to deal with eventing and different event formats, then orchestration becomes a good candidate as well. So it depends on what you're trying to do and how much flexibility you need and how much centralization you need. So there's no right answer per se, and you can do both. But these are some of the guidelines that I use when I'm deciding between choreography and orchestration. And also you can take a hybrid approach, right? You can, for example, have a bunch of services that are tightly coupled together, put it in an orchestration. And then this orchestration, when it's done, maybe it sends messages to other orchestrated bounded contexts. So in this model, you're using orchestration, but you're also communicating between these orchestration contexts using messaging. So it's the hybrid approach. It's possible as well. All right, so that hopefully explains what I mean by choreography and orchestration. Now I want to very quickly look at the landscape on what kind of tools we have here, and then we'll look into orchestration in a little bit more detail. Now, in terms of landscape, for event-driven architectures, no matter where you are with AWS, Azure, Google Cloud, you have a lot of choice. So Event Bridge on AWS, Event Grid on Azure, Event Arc on Google Cloud. These are all very similar products that basically help you to get events from one place to another place. And you also have open source solutions like Kafka and other projects like Pulsar and Solus and all that. So there's a lot of products and open source projects out there for event-driven systems. Now for orchestration, there's less choice because it's something relatively new. So on AWS, you have step functions. Azure has logic apps. Google Cloud has workflows and Cloud Composer, which is workflows is for orchestrating services. Cloud Composer it's more about orchestrating data. And then you have open source projects like Apache Airflow that you can use as well. And then finally, there's also a serverless workflow specification. This is an open source specification from CNCF that basically tries to come up with some standards on how workflows are defined and how they are executed. It's still in early stages, and none of these products that I talked about with step functions and logic apps, they don't implement the specification yet. But maybe it will be something that kind of underlies all these technologies at some point, but it's something to keep in mind. All right. Now I want to zoom into orchestration and go look at Google Cloud's workflows, which is Google's answer to orchestration, and just give you an idea what kind of things that you can do with workflows, so that you kind of understand what is possible basically with orchestration. Now, what is workflows? It's basically a service to orchestrate and integrate other services. And you might ask, like, what kind of things I can orchestrate? Well, first, you can orchestrate code running in different places. So we have on Google Cloud, for example, we have App Engine, Cloud Functions, we have Cloud Run to run functions, applications, and containers. So all of these, they're HTTP based, and you can use workflows to orchestrate them and call them in the orders that you want. On top of that, you can call any Google API. So any Google Cloud APIs, such as Vision API, Machine Learning API, or any Google API that basically talks over HTTP, you can include in your orchestration. And you can even include external APIs. So if you have some Azure API that you want to call and get the result, you can do that. If you have your own API running in your own data center, as long as that API is publicly available, you can call that with workflows and get the result and use it in your orchestration. So it's a very extensible kind of orchestration framework, and I like that you can pick and choose like different things and kind of put them together with workflows. Now, how do you define these workflows? There is basically a YAML or JSON syntax that you can use, and in this YAML, here I'm showing YAML, you have steps. So for example, in here, if you want to call payment processor and then shipper and then the notifier that run on Cloud Run, Cloud Functions, and Cloud Run again, you define 3 steps. You can name the steps in any way you want. Then you can specify how you call these steps. So you make an HTTP post call with these arguments, and then workflow makes this call for you. Then it gets the result back. So it makes this call with the input that you specify. Then it gets the result back. And then you can use that result in the next step. So here we get the result of the process result, and we pass that to the next step, which is ship items. Then we make the call again to shipping function. We pass in the result body, and then we get the result of that and pass that on, and so on and so forth. So you define the steps and also what goes in the inputs and outputs and pass them around, which is pretty cool. So as I mentioned, there's this notion of steps in workflows that you define in YAML. There's this notion of serverless pause. So for example, if you, in your shipper service, maybe you want to make a call to the next notifier service, but you want to wait a little bit, wait like 30 minutes or something, you can tell workflows to do that, wait for 30 minutes, and workflows will do that for you. And then you have this variable passing between steps that I already showed you. And you also can parse the results. So you can parse the results of what you receive from each step. So there's this JSON parsing syntax built into workflows. That's very useful. On top of all this, there's errors and retries. So let's say you want to apply this global policy where if a service fails, you want to try maximum 5 times, but you want to do this in an exponentially back-off kind of way. You can specify that in workflows, and then every time a service fails, that policy will be applied. Similarly, you can take different actions depending on success or the error of your service. So if something happens successfully in shipper, then you can send that result to notifier service, for example. But if the shipper fails with certain HTTP code, you can send that to another service called pager and maybe escalate to your support. And you can do conditionals in workflows. So for example, in this case, we are reading our database with workflows. We get our inventory. We can check that inventory within workflows to check certain number, for example. And if we determine that we are out of stock, we can go one way or we can go another way. So you can specify this logic within workflows itself. And you can make calls to third-party API. So here, for example, we are making a call to the supplier API, and this can happen easily within workflows. And there's other useful features like sub-workflows where you can create workflows and use them for multiple places. It's kind of like a method call, but for workflows. And we make it really easy to connect to Google Cloud Services by providing connectors to those services so that you don't have to specify the HTTP HTTP call yourself directly. You use connector instead. It makes it easier. And deploying a workflow, it can be done from command line. So deploy, execute, and see the result this way. But there's also UI. So you can see here, I define my YAML. This is my workflow, and I can see a visualization of that. And then I can also execute it from here if I want to see what happens. All right, so this was a very quick introduction to workflows and orchestration. And I won't be able to talk about this in too much detail because we're already running out of time. But I just want to mention that we have this app called Piccadilly, which is a picture sharing app that we built for a customer in London. That's why we call it Piccadilly, because it combines the Piccadilly area in London with the pictures sharing app. Initially, and this is that, by the way, where you upload pictures, and it uses machine learning to detect the labels of the picture and also draw a border around the picture using, again, machine learning to extract the colors of the picture. But what I want to show you about this app is that we initially built it using event-driven architecture. And this is the architecture. I won't go in detail about what happens, but in a nutshell, when the user uploads a picture through a front end, it goes to a bucket. And then in this bucket, we basically emit a bunch of events. So one event goes to this service, another event goes to this service, another event goes to this service. And then a lot of things happen to basically create that picture and labels and all the things that I showed you before. This was done in an event-driven way, and we rewrote it using workflows, using orchestration. So we went from this to this, where the whole process is captured in a workflow, and the workflow does the work for us. So the workflow calls the Vision API, it calls the services in the order that it's supposed to happen. So we transformed that, and I won't be able to go through in detail like how it's different from event-driven and orchestration, but I just want to talk about the lessons learned, what we learned in this transformation, because I think that's the important point here. So what we learned in this transformation from event-driven to orchestration is that, first of all, going to orchestration simplified a lot of things for us. We went from handling 3 different kinds of events and parsing those events to simple HTTP calls, and this was very refreshing, and it simplified our code in a big way. Our code was simplified with no event parsing, and we could even get rid of some services because, for example, for image analysis, we were deploying a service, but instead of deploying to a service now, we can make a call from workflows directly to Vision API. And also we had a garbage collector service, we got rid of that, and we just made calls from workflow. So we had less code, simplified code. We had less setup because we didn't have to set up this eventing construct, so we didn't have to set up PubSub, scheduler, event arc. And finally, error handling became really easy because workflows was making the calls. So if something failed, we could see it very easily in workflows. On the other hand, workflows was something new that we had to learn. So we had to learn its quirks and limitations. We had to change from code to YAML. So in some cases, we got rid of the code, but we had to do that call in YAML, and it's a question of style, I guess. So you have to decide which one you prefer. Code is easier to test and write, but YAML makes it so that it's not a service anymore. You can just rely on workflow. So you have to think about that. You know, debugging, testing, logging is quite early stages in workflows, and there's no IDE support, so that was a little bit challenging. We lost parallelism because workflows does things in a serial way, although there's parallel tasks coming up, but that was lost, so we realized that. And also the flexibility that we have with eventing, we lost it because now we have to do things in a certain order, and if you need to plug in something, we have to include it in our workflow, so it's not as flexible as eventing. All right, so if you want to learn more about workflows, this is the link. As I mentioned, this application is actually a part of a workshop. So if you want to build this application, there's a serverless workshop that you can check where we have 6 labs, and you can build the whole app yourself if you want. And the code is already on GitHub open source. So you can see the event-driven code, and you can also see the orchestrated code all on GitHub. And if you have any questions, feel free to reach out to me. This is my Twitter. I will be very happy to answer. I will just stop here because I'm out of time. So thanks for listening. Hopefully this was very useful to you. Thanks very much.